Corporate finance practice problem using OneNote. Deferred annuity. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we have the tab on the left-hand side. We're in the practice problems. We're in the 950 deferred annuity tab. Also note that when using OneNote, you might want to look at the immersive reader. Many of our presentation files often have a complementary text file. The text files have, in essence, a transcript in them, transcripts that can be translated into multiple different languages and both heard as well as read in multiple different languages, thereby being a good complement to the practice problems up top. Closing this back up, we have our information up top. We're going to be populating that information into the blue areas on down below. Like with prior problems, we'll typically be doing each component with multiple different kind of calculations as we go. So the scenario, we have a deferred annuity. The annuity starts 2 years from today. So we have an annuity type of calculation that we're going to be looking into. The added issue here is that the annuity doesn't start immediately. It's going to start within 2 years. It's going to be then the payment amount of the $25,000, and then we have the years of the 10 years, and the rate is going to be 14%. So what we want to do is the present value of an annuity, but we want to bring the present value all the way back to the current day now, even though the annuity doesn't start for 2 years. A couple ways we can do this. The most common way that you might think then would be to use the present value of the annuity formula. That's what we would think to do. But when we use that, of course, that present values it back to the starting point of the annuity. Once we get to that point, the present value of the starting point of the annuity, if it begins 2 years later, we still have to present value it back to today. So therefore, we can then use a present value of 1 calculation to get it back to the current time period. Also note that if this would be less common if you did like a book problem or if you did it by hand. But if you have Excel, you can also break down the annuity, if it's a 10-year annuity, to single payments of 1 and simply break them all the way down to the current day. So you'd have 10 payments that you're going to present value back to the current day instead of an annuity that you'd present value to the first day of the annuity and then present value that back to the current day. So we'll take a look at both of those methods. Obviously, a book problem is trying to get you to do the 2 methods. If you see this in a book problem and you want to make them happy, if it's in a book problem, you want to do the present value of the annuity and then present value back to the current day. If you have Excel and it's only 10 periods, it might be useful then to do the other method, just present value each payment back all the way to the current day, which we will take a look at. It then depends on what your presentation purposes are for both calculations. Calculations aren't the difficult component then, but presentation, how you're going to show this to yourself or explain it to others. So we'll start off with the present value of the annuity here. That's going to be the P times 1 minus 1 plus R to the N over R. We'll take a look at some other ways we could do this, including Excel and so on in the future, a formula, a function in Excel and whatnot. But we'll start off with the mathematical formula. We're going to break that out into a table format as we have seen in the past. P and then this whole thing being in the outer column. We'll break out the more detail, including the numerator, since it's got the most detail into the inner columns. So we're then going to have the 25,000. That's going to be P. We're going to take then the inner component. I'm going to break out the 1. I'm on the numerator now. 1 minus. Then we're going to pick up the 1 plus R to the negative N. I'm going to pull that into the inside. We've got the 1 plus the 14%, which is the rate. That gives us the 114% to the power of negative N. And negative N being the number of periods. That's going to be 10 in this case, because we're looking at the annuity, even though the annuity doesn't start for 2 periods out, because we're bringing this back to the present value of the annuity. Also note that when you calculate this with a calculator, you're going to need something that takes this to the power of negative 10. You could use a scientific calculator. If you're in Windows, you can go down to the scientific calculator here. I'll do the whole thing. It's going to be 1 plus the 0.14. That's going to give us the 1.14, 114%, same thing. Then I got to take that to the power of negative 10. So we'll take that to the power of 10 down here. And then I got to make it a negative. Hold on a second. Let's do that one more time. We're going to say this is going to be 1 plus the 0.14. And then I need to take this to the power of, that's going to be the caret up top. And we'll take it to 10. I need to make that a negative, so after I enter the 10, I hit the negative here, and then enter, and that should give me my proper number. So I'll go back up top. I'm going to change it back to a standard calculator and do this to it. And then we'll say, then we could take the 1 minus that number we just came up to. That's the 0.730259. And then we're going to take that and divide it by the numerator divided by the denominator, which is 14%. So this 0.7302569, something like that, divided by the 14% is about the 5.216115. Then we have the P times that amount. In other words, the 25,000 times that gives us the 130,402.89. So that would be the present value of the annuity now, but that's not really the present value as of today because the annuity doesn't start for 2 periods out from today. So once we get to this one lump sum number, we can then use the present value of 1 calculation to bring that back to the current day. That'll be the second part of the problem here, but we're going to do this calculation a couple more times. If you want to skip forward to the second part, you can take a look at that. We'll do this calculation again, thinking about it in terms of running balances now. And I'll also think about the running balance scenario on the right-hand side, where we can skip the annuity formula and just do a running balance present valuing all of the payments. So let's consider these options. So we'll say, first, I'm just going to do a running balance and just think about how we can break out an annuity into present value of 1 calculations. So you could typically do this with the annuity calculation. I won't do the present value calculations each time, but you can imagine them being done in Excel quite easily in a table format like this. And you can recalculate the annuity by saying the payment's going to be $25,000. If I take present value of that $25,000, which is 1 period out, then I'm going to get that $21,930. And then if I add to that the next $25,000 payment, but present value it being 2 years out, therefore the present value being less, then I get the $19,237 about. If I add that to the prior value, the $21,929.82, we get the $41,166.51, and so on. Third payment, $25,000, present value present value of 1, 3 periods out, now at the $16,874. That plus the prior balance, $41,166.51, gives us the $58,040.80, and so on, bringing us down to the total balance, if we were to do this, of the $134,02.89. So, and that's basically the same thing we got with the annuity. So remember, it's an annuity, but I don't have to think of it as an annuity. I can think of it as present value of 1 calculations, just I'd have to do 10 of them, which is somewhat tedious to do, not difficult in Excel, but then I have to think about how I'm going to think about it. It's nice for me to look at this if I want to look into the detail. If I'm going to present it, then it might be easier to just give 1 number and whatnot. But you can apply the same concept and say, well, what if I just did the same concept but present valued it all the way back to the current day? In other words, this first payment as of today, because the annuity doesn't start for a couple of years, and the annuity typically means that you have a payment at the end of the annuity, then the first payment is actually 3 years from today. So I could just say, well, why don't I just take that $25,000 and present value it instead of back to the first day of the annuity, which doesn't start till 2 years. Why don't I just present value it all the way back to today, 3 years out, and then I can just eliminate the annuity altogether, meaning I do the same thing, $25,000, present value 3 years from today. That's the first payment of the annuity when it actually starts as compared to today, bringing it back to $16,874. And then if I continue on that, the next payment of the annuity is actually 4 years from today. And I would then present value that. We would get the $14,802. That plus the $16,874.29 gives us the $31,676.29, and so on and so forth. And if we were to add this up, we would get to the $100,340.79. So in this method, I can just skip the annuity altogether. I could say, well, I'm not going to do the annuity. I'm just going to present value all 10 payments back to the current day, and then I don't have to do the second step. So you could think about it that way. Probably not what a book problem's looking for, but in practice, definitely viable. And so you can kind of think about how you want to structure this. So we're going to keep on going with this one. The end result number, we should get to that 340.79, but we're going to do it in a 2-step process. We got the annuity now of the 134.02.89, and then we're going to present value that back 2 years to the current day, and we should get to this 100,340.79 and that method. So before we do that, though, let's do this again with the Excel equation. So if we took the Excel equation And now I'm present valuing the annuity. It would look something like this. We'd have the present value of the rate, 14%, comma, number of periods. That would be then 10, because now we're looking at just simply the annuity, even though that doesn't start for 2 years out, and then comma, the payment would be the 25,000. The 25,000 at the payment. That then gives us, once again, that 134,0289 present valued as of the start of the annuity, which is still 2 years out, which I'd still need to bring back to the current day, which we'll do in the second part of the problem. Lastly, however, with this part of the problem, we can see it with the tables. So I'm looking at the tables for 14% and 10 years, 10 periods, 14 and 10, and the tables aren't here. So I'm actually, I'll assume the tables. I won't go down there and find it. But if I found the 14 and 10, that should come out to the 5.2161, and the 25,000 times the table amount would give us, once again, 134,0250, close to but not exact to what we have up top due to the tables, which would be rounded. Is it exact? No, not exact. Okay, so now let's go down and do the second half of the problem. So now that we have this number, and we're using the more exact number up top, which is the 134,0289, then we need to present value that using a present value of 1, because it doesn't start till 2 years from today. So now we're going to do that present value. We're going to say, all right, let's present value it back. That formula is going to be the present value equals the future value times or over 1 plus r to the n. Putting that into our table type format, we're going to take the 134,0289. That's what we got in a prior component, the present value of the annuity. Then we've got the 1 plus r to the n. And so we're going to say 1, and then the rate is 14%. So the 1 plus the 14% is 114 to the power of 2, because that's the number of periods, because the annuity starts 2 periods out, and we have this as at the beginning of the annuity period that we need to bring back to period 0. So then if we take the 114 to the power of 2, we get the 1.2996. And then we could take the numerator, the 134,0289, divided by the denominator, the 1.2996, getting the 100,340.79, which I think we saw prior to this in like that running balance type of calculation. If I was to divide this out, the 100,340.79 divided by the 134,0289, we'd get the amount we would expect to see on the table, although the table will typically round it to 4 digits, 3 or 4 digits. So that's going to be the answer. We'll calculate it a couple different ways now. Let's just think we could do the same kind of thing with the present value of an annuity calculation within Excel, which would be the present value of the rate, 14%, number of periods, which would be now 2 periods, because we got 2 periods out, not a payment, because now we're present valuing 1 instead of an annuity. The future value then would be that 134,0289. That would once again give us our 100,340.79 again. We can also think about it in terms of the tables. Do I actually have a table down here? I do. I have a table this time. So if we have the table, then we could take the 134,0289 times the amount on the table, which is 14 and 2 periods. So 14%, 2 periods, 0.7695. So 0.7695, the 134,0289 times the 0.7695 gives us, once again, the 100,345.02. Similar, not quite exact to the 100,340.79 up above due to the tables not being exact, rounded to 4 digits. Also note that if we go back down and take a look at the running balance, we could also see that running balance. This is what we saw before, but just remember that you could think about this whole thing and just say, I can just do a present value of 1 all the way through it. So when you see this annuity, you're going to say, well, this looks like an annuity. It's a 10, and it is. But, you know, if it starts 2 years out, I could just convert the annuity to present value of 1 calculations and start them when the annuity starts paying. And that could actually be easier in some cases if using Excel. So it really depends on your presentations, what you're doing it for, what are your tools that you're using for it, and then how do you want to present this information. So in other words, this 25,000, I could say it starts year 3 because the annuity is 2 years out and you start the annuity at the end of the year. So really that payment happens kind of 3 years out. And I pull that back to the present value simply using present value of 1 calculation, giving us the 16,874.29. The second payment is actually 4 years out. Present valuing that would give us 14,802 plus the prior balance 16,874.29 gives us the 31,676.29. And then the third payment is actually 5 years out, present value in that 12,984 plus the prior balance 31,676.29 gives us the 44,660.51, and so on. If we then look at the total periods, which are 10 periods, but they started at 3 years out, then we get to that 103.40.79, which matches what we have up top, I believe. Here it should, 103.40.79. It does. I was getting hesitant. Like, I knew it matched. I knew it would. But we do that and we kind of eliminate the annuity. So once again, a book problem's probably not going to like that method because they're trying to get you to do the annuity and then the present value. But in practice, might be a good way to think about it. And what you want to do, of course, in general, is just understand the relationship between these things and when the best method would be for presentation purposes and just analytical purposes.